Hi, this is Victor and welcome back to my math tutoring channel. In this video, we will do some example of the development of the sigma notation. We will develop some example with the sigma notation. I will start with the first example, which is sum I equal 1 to 5 of I times I plus 1. You can do it without the formula, but if it is I equal 1 to 100, it will take you 100 years maybe. But with the formula, it will take like 2 seconds. I did it from 1 to 5 to show you how to do it without the formula. So without the formula, the first time I is equal to 1 times 1 plus 1 is 2. The second time I is equal to 2, 2 plus 1 is 3. The third time I is equal to 3 and 3 plus 1 is 4. The fourth time I is equal to 4, and then 4 plus 1 is 5, and the last time, the fifth time, I is equal to 5 times 6. If you do that calculation, 2 plus 6 plus 12 plus 20 plus 30, you will have 70. Now, I want to try to do it with the formula to see how easy it is. So if I have I equal 1 to 5, I times I plus 1, this I can write it like this, I equal 1 to 5, and I will develop my parentheses. It become I square plus I. So this I can divide it into two sums. The first sum I equal 1 to 5 of I square plus the sum of I equal 1 to 5 of I. Now I will remind you of the formula of, I will do the first one, I square, and I will remind you of the formula of I square. The formula said sum I equal 1 to n of, let's call it k. Actually, we'll keep it I, of I. The form of I square, the formula is the n that is here, it become n plus 1 times 2n plus 1 divided by 6. So I will take that formula. No. I will put it here. Let's shrink it. Put it here. And I will apply it for this one here. So the n that is here, it become here. So here I have 5. So my n become 5. So this become 5. 5 plus 1 is 6. And 2 times 5 is 10 plus 1 is 11. So I applied the formula that is here divided by 6. Plus, and now I will take the formula for sum of I equal 1 to n of I, which is equal to n times n plus 1 divided by 2. So I will take that formula and I'll shrink it. I'll put it here, and I will apply it. I will apply it for here. So n is 5, this, and n plus 1 is 6 divided by 2. So if I want to add this, 6 divided by 6, I can take it out. So this become 55 plus, and 6 divided by 2 is 3, 5 times 3 is 15, and this is 70. So I got the same answer like that, but here I applied the formula. As I said, when I is equal 1 to 5, it's easy, but if I equal 1 to 1000, then it will become very hard for you to do it without the formula. Let's do another example. Sum of I equal 1 to 6 of k time I3. Now the sum is for I, so k is a constant. I can take k outside my sigma notation. I equal 1 to 6 of I3. And the formula of sum of I equal 1 to n of I3 is equal n square times n plus 1 square, and all that is divided by 4. And the n that is here is the n that is here is the n that is here. So I will apply this formula here. I will apply it here. So it will become k, I equal 1 to 6, and my n is 6 here, square time 6 plus 1 square divided by 4, which is equal 36, and 6 plus 1 is 7. 7 square is 49 divided by 4, and if you do your calculation, you will have 441. Not times here, 36 times 41. You will have 441, but don't forget the k here, so my answer will be k times 441, and k can be any number, 2, 3, 4, whatever. It can be positive or negative number. Now I will do two other example, and I will end up this video. There is sometimes I have a sigma notation for something that there is no formula for it, and I'll give you an example. I equal 1 to 100, 1 over 10 to the power of I. So I don't have any formula for that. So all what I have to do is, the first one is 1 divided by 10 to the power of 1, plus 1 divided 10 to the power of 2, plus 1 divided 10 to the power of 3. And I'm not gonna do it till 100. And I will see if I can find a pattern to find my sum. So the first one here is 0.1, the second is 0.01, the third is 0.001, and the fourth is like I will have 3 zeros and 1. So the 100, it will become 0.11000. Let me do it in a better way. So I have 3 point here, plus the 1 over 10 to the power of 100 is 0.0001, and here I have like 99 0, and then the 1. I have 99 0, and then the 1. So if I add those, 0.1 plus 0.01 plus 0.001, it will become 0.11111, and then 100 time here. 100 time 1. So if I can find the pattern, I don't have to do it till 100. So you find the pattern, and then you write down your answer. And I'm sure the teacher is not gonna give you in the exam something that there is no pattern to it. Let's do the last example, like it can be a trigonometric function too. So let's do one with trigonometric function. The sum I equal 1 to 8 of sine k pi over 2. Actually, let's put the parentheses in a better way. K pi over 2. So the first term is going to be k is equal to 1. It's going to be sine 1 times pi over 2 is pi over 2. The second one, k is equal to 2. 2 times pi divided by 2 is sine pi, plus sine 3 pi over 2, plus, if you continue till sine 8 pi over 2, which is 4 pi. So I can replace this with 4 pi. And as I said, we try to find the pattern. So sine pi over 2 is equal to 0, sine pi is equal to 1, and 3 pi over 2 will be will be minus 1. And then if you continue, you will find the pattern plus 1, minus 1, plus 1, minus 1, and it will be equal to 0 because 8 is an even number. If it is an odd number, it should be either plus 1 or minus 1. So that's it. In my second video, I will do how to go from the sum to the sigma notation. I will do some exercises. And if you like my video, please subscribe to my channel. And I would appreciate if you put a like or leave a comment. This way it will help me continue to whatever I'm doing, and it will help you pass your course. Thank you.